Alright, when we have a quadratic equation, quadratic just means x squared, it would make sense that you'd want to solve for x by using a square root. Unfortunately, many times it's not that simple, because a quadratic equation can have x squared, but it can also have x, and so the issue becomes, well, I'd like to take the square root of the x squared, but what do I do with this x? Alright, so that's kind of what we're going to look at today. So first of all, I want to address what happens if there is not an x, if there's just an x squared. This is a quadratic equation. We're trying to solve it, which means tell me what x equals. Okay, so this is pretty simple. The first thing you do is get the x squared by itself and then take the square root of both sides, right? And that makes complete sense. So subtract 7 and divide by 2, so x squared is going to equal negative 7 halves. Now if you're solving this for real numbers, there's no real number that you can square to get negative 7 halves. So there's not a real solution, not a real number solution. But you can solve this using complex numbers, okay? So that's what we're going to do here. There's not a real number solution, but you can solve it using complex numbers. So you take the square root of both sides, and the square root of x squared is x, and the square root of negative 7 halves, you have to consider the positive and the negative square root of negative 7 halves. So what this means, if you don't realize it, is it means x could equal the square root of negative 7 halves, or x could equal the negative square root of negative 7 halves. So see how one of these is a positive square root and the other is a negative square root. Underneath you still have the negative 7 halves, okay? And this is called plus or minus. So you'd read this as x equals plus or minus the square root of negative 7 halves. Now you could simplify this further, of course. So let's go through the simplification, and I'm going to avoid this for a moment. Well, first of all, the negative can come out of the square root and become an I. A lot of people make the mistake of putting the I in front of the plus or minus, but that's not where it goes. The I is multiplied by the square root, so it goes right in front of the square root, okay? So we end up with plus or minus I times the square root of 7 halves. Now, I personally would like to stop here, but typically we rationalize denominators, meaning we can't have a square root in the bottom. This is the same thing as plus or minus I times the square root of 7 over the square root of 2. And then we rationalize this fraction by multiplying the top and the bottom by the square root of 2 so that we don't have this square root on the bottom. So we end up with plus or minus I. On top we have the square root of 14. On bottom, the square root of 2 times the square root of 2 is the square root of 4, which is 2. And there are the complex number solutions. Okay? There's not a real number solution, but there are two complex number solutions. I times the square root of 14 over 2, or negative I times the square root of 14 over 2. Again, taking into account that plus or minus. Also, real quick, how it depends on how comfortable you are with complex numbers or fractions and square roots, but this I could also be written on the top as I square root 14 over 2, or negative I square root 14 over 2. Some people prefer to write it like that. So that's a basic one where you just have x squared. It makes sense that you want to take the square root to solve for x. Now this one is still a quadratic equation because of the x squared, but now this has an x in it. So if I get x squared by itself, I'm going to have this x floating around, so I can't use that strategy. But what I can do is turn this into a perfect square by adding something to it, and then I'll end up with something like this: x factored squared equals a number. And then I can take the square root of both sides. So I'm not going to take the square root just of x squared, but x with some number inside. So that's kind of our goal here, okay? And to do that, we have to complete the square on the x guy. Alright, so let's go through that process. Now, I could complete the square on these the way they sit. However, completing the square becomes much simpler if I have one x squared. And luckily, this is an equation that has two sides, so I can do whatever I want to both sides as long as I keep it balanced. So the first thing I'm going to do is divide both sides by 4. And what that's going to accomplish is giving me 1x squared in the front. Now I'm going to separate my constant over so I can focus on these guys to complete the square. Then I need to add something to both sides to make the left side a perfect square trinomial, and I have to add it to both sides to keep the equation balanced. To figure out what to add, I will factor my pretend trinomial over here as if it's a perfect square. To get x squared, I have to have x and x, and to get 2x in the middle, I need a plus 1 and another plus 1. And so 1 times 1 gives me 1, and so that's what I have to add to both sides. So 7/4 plus 1 is 11/4. So I end up with x plus 1 quantity squared equals 11/4. And notice now I've got what I need over here. Now I can take my square root after I've completed the square. So the square root of x plus 1 quantity squared is just x plus 1. And then I have to take the positive and negative square root of 11/4. I'm going to simplify my square root. It's the square root of 11 over the square root of 4, but that's just 2. Finally, I'll subtract 1 from both sides, and I see that x equals -1 plus or minus the square root of 11 over 2. So I get two solutions for x, and they are real numbers. They're not complex numbers because there's no I. The two solutions are x equals -1 plus the square root of 11 over 2, or -1 minus the square root of 11 over 2. So see, my plus or minus could be a plus, or it could be a minus. And that's how you get two solutions out of that. And now we've solved this equation for x.